Hello, welcome back. Today let's try to solve another Leetcode problem, 714, delete and err. Now let me explain the question. So for example, we have array nums 3, 4, and 2. So we can get this num 3. And then we cannot get 2 and 4. So our final result is 3. But what if we take the numbers 4? Yeah, so 4 minus 1, it means we cannot take 3. And 4 plus 1, it is 5. We cannot take 5. But for the next step, we can take 2. So the final result is 6. Now let me go to the whiteboard to explain my solution and then go to the code editor to finish the coding. Basically, this is similar to the house rob problem, but just the representation is different because we are just giving an array and we have some requirement. So the requirement is if a number is bigger than this 2, bigger than 1, yeah, so it means if we take the number 2, if it is 3 or 4, if it is this number minus 1 or plus 1, we cannot take it, we have to delete it. Yeah. So for example, if we take number 2, it means the 3 will be deleted. Yeah. And our result is 2. So what about the next step? So for the next step, we can also take a 2 and final we're gonna take a 4. Because if we take a 2, all the 3's will be deleted. And then we're gonna take a next 2, 3 and 1 will be deleted, already deleted, it is just 2, and for the last step, it is 4. But that is not the biggest. The biggest number is we have to take a 3 first. If we take a 3, all those 2's and 4's will be deleted. Then we're gonna take a next 3 and next 3. So our final result will be 9. So 9 will be the maximum. So how should we solve this problem? If we solve it directly using this array, as we can see that it can be difficult because the numbers are not sorted and there are so many duplicate numbers. Yeah, so if we turn this problem into a DP problem, it might be easier to solve it. How can we turn this problem into a DP problem? Because we are always dealing with the nums. If inside a nums is n, it is n plus 1 or n minus 1. So how should we represent the nums? Yeah, we can also use array index to represent the nums. So for example, if this index is n, so what about its neighbor? Of course, here at the right side it is n plus 1. At the left side it is n minus 1. If we represent all those numbers, put it into the index, and all those numbers will accumulate to the index. For example, if this is index 3 and the 3 plus 3 plus 3, so this person will be 9. Yeah, if this index is 4, so yeah, let me put it here. So if I use the index 3 after accumulation, this will be 9. So this means at index 3, this number, what is the total of this number? Because for my deletion, I only need to delete all the numbers. If I take 2, all the 3's will be deleted. So I need to accumulate all of them. At index 4, so how many 4's? There's only 1, it will be 4. At index 2, there are 2 of number 2. It means this will be 4. After that, you can see that it will turn this problem into a house rob problem. Why? Because, for example, this is the index 0, so the value is 0. The index 1, the value is still 0 because there's no such numbers for number 1. And there's no numbers of number 0. It doesn't matter. But for our calculation, so what we're going to do, if we are going to take from the index 2, yeah, let's try an example. If we take the index 2, can we get the maximum value? Yeah, it means we have two solutions. We can take this number or we cannot take this number. Yeah, if we take this number, it means we're gonna take this number 4. But what is our previous value? If we take this number, our previous value have to come in from the what? From this index minus 2. It means from this 0. Yeah. Now let me prepare the DP array. So for our DP formula, it will be the DPI. So DPI means the maximum value, maximum profit, or according to the question, it is the biggest number, yeah, maximum result we can get at position I. So here I'm gonna start from the index 2. So if I start from the index 2, let's deduct the DP array. So it will be the maximum of which value? Yeah, it always depended or if we take it or if we not take it. If we take this value, it means the DPI plus DPI minus 1, right? Yeah, because we cannot take the neighbor, its neighbors, because this index is 2, it means the value is 2, here the value is 1. If we take value of 2, we cannot take value of 1. For our DP array, we can always check for the previous places, but we can never predict the future. Yeah, only when we go to this index 3 can we know the state. We can never predict what is the next state because it doesn't matter. Anyway, we will go to the last state. So here the DPI will plus DPI minus 2. So this means we're gonna take this number. We have to take the index from 2 steps before it. And another value is DPI minus 1. So this means we're gonna not take this number. If we're gonna not take this 4, it means the maximum value can be the 1 before it. Yeah, 1 step before it. So it means it is a DPI minus 1. Yeah, let's try to solve this according to the example. So here, let's start from this number 4. So from here, we know the maximum is DP, this number 4 plus 0 and 0. So it is 4. What about the next number? It is 9 plus this 0 compared with this number 4. It is 9. And what about here? It is 4 plus 4, it is 8, but this number is 9. So here it will be 9. So we just need to return dp minus 1. So this will be the final result. Yeah. Now let me go to the code editor to finish the coding. So as I explained, we're gonna need to prepare a dp array. So the dp array will be 0 from the beginning times. So the 0 should times the max of nums because we need to use this array to represent all the numbers. So what is the biggest number? So it should be max nums. And then we need to plus 1 because we're going to start from the index 0 and each index will represent the numbers. So this means the max of nums should also plus this 1. Yeah, only in this way can we use index to represent the values of the numbers. Now, we can just loop through the dp array to check our result. So for I in race, we can directly start from the index 2. It means the third number because the first is 0, the second is from the value of 1. It is okay, but we're gonna start from the value of 2. It means index 2 to the length of dp. Our final return will be the dp minus 1 because this is the representation of dp. It is the maximum result. Now we just need to update the dp array. So the dpi should equal to the max of dpi plus dpi minus 2. So this means we're gonna take this number. And another case is the value before it. It means we will not take this number. If we didn't take this number, it is a dpi minus 1. Now, this is our result. Now let me check it. Oh, I didn't prepare something. I forgot to put the numbers inside. That is why it is wrong. Because, as you can see, it is just zeros inside of the dp array. I didn't do any calculations. Yeah, so this is why the output is 0. Now, we just need to put the numbers accumulated inside of the dp array. So, for n in nums, so the dp n should plus equal to n. So this means at each index here, I'm going to accumulate these values. For example, this is a 2, nums 2, it means my index 2, I will plus a 2. Next time I will plus another 2, it will be 4. So yeah, now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. And by the way, this is just an ON solution. As you can see, there are just two for loops, and each for loop is ON. As you can see, it passed, and it's pretty fast. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you next time.